Hello everyone, in today's video we will talk about twosome problem. So in twosome problem there are three approaches. So there is first approach which is brute force approach in which we use two loops and the time complexity for this is big of n square and space complexity is big of 1. But if if the array is unsorted then the better and the optimal approach is the hashing method which we will understand further. And if the array is sorted array, then the optimal approach is two pointer approach. Okay, so we will understand the all three in this video. Okay, so firstly, let's talk about the twosome problem. Twosome problem, brute force approach. So in brute force approach, we will apply apply two loops. The first will be, let's say first is I, uh, I is at 2 and the j is start from there. Then we will do the sum. Is it equals to 9? Yes, equals to 9. So we will return the indexes of them, which is 0 and 1. Let's take another. So I is there and j is there. We do the sum. Is the sum equals to target? No. So we will move further. I is there and j moves there. So, is it sum equals to target? No, it's not. So, as the j reaches the at the end, we will move the I there, and j will start from further. Is it? Is it? Is them equals to target? Yes, it is equals to target. So we will return their indexes, that is 1 and 2. Okay, so this is the problem, and it is very brute force approach, and the time complexity is big of n square, which is not which is not acceptable. So we will move further to hashing method. Okay, so yeah, now in hashing method what we will do, we have an array, we have a target. What we will do, we will create a map. Let's see this. So we create a map, an ordered map intent, and we will store the element, we will store the element and its index. So let's take, if I have let's take by this example 4719. We have a 4. We store the 4 comma 0, and we also calculate at the at every iteration the remaining part. The remaining part is target minus array. So if target minus array is already in the map, then then the sum of this array of I plus remaining is equals to target. That means the both the elements which having the sum equals to target are present in the array. Therefore, we will return the array. Let's understand it by example. Example. Yeah. So, firstly, we are at fourth. We are at 4, and as when we calculate the remaining is equals to target, which is 8. 8 minus 4 is equals to 4. And as the initially the map is empty, so there will be no element 4 in the map. So not found, we will move further and we will go to 7, where I is equals to 1. Now we'll calculate target minus array of I, which is 8 minus 7 1. Now at previous iteration, we store the 4 comma 0 in the map, and we are finding 1. The 1 is not, 4 is there, but 1 is not there, so not found in a map. We will move further. Now when we move further, the I is at 1. Now we will find the remaining is 8 minus 1 7. Now 7, firstly we store the 4 comma 0, then we store the uh, 4 comma 0 7 comma 1, and now we finding the 7, and 7 is already there. in the map. So we found that, and we will add the 7. We will add, we will add 7, that is this, and 1 to make the sum 8. Now understand it with the code. So there is a map which we declared. Now for every loop, we finding the need or remaining, you can say. Now need is equals to target minus nums of 5. So if I am at 2 and the 9 minus 2 is 7, so need is 7. Now is it is it 7 is in the map? No. So we will move further and we will store this 2 comma 0, which is index 0, 2 comma 0 in the map. Then we move further, we move further. Now let's go to 7. Now need my target minus, that is 9 minus 7 is 2. Yo, it's 2. Okay, so need is 2. We find 2. Is it 2? Yes. We will store the 2 comma 0 in the map. So 2 is present. 2 is present in the map, so we will return the mpp of need, means its index, that is 0. So MPP of need, which is 2, and which is 2, MPP of need is 2, and the index is 0, and I is 2, sorry, I is 1. We were at I is equals to 1, so it will return the 0 comma 1. Okay, so it was the map approach. If we talk about the two pointer approach, which is only applicable for the sorted array, is this. Okay, so firstly, the first step for this is the array should be sorted. So we will sort the array. Then the left pointer is at the starting and the right pointer is at the last. Okay, we will add both of them. Is if it is greater than target, which is it is greater than target, so we have to remove the largest part. The largest part is at the right, so we will move the right to uh, 10, or at the 4. Okay, we will move the right. Now we will add, when we add the sum is 2, which is less than 16, so we'll add some more thing, some larger part. So we will move the left, and we move left. Now if we do the sum is 11, which is obviously less than 16, so we will move further left, because we want to add some largest. Okay, now the sum is 14, which is also less than 16. We'll move further left, and now the sum is equals to 16, uh, which is equals to target. So we'll return their indexes, that is 3 comma 4. Okay, if I talk about the code, uh, we will apply the loop until the left crosses the right. Okay, so when left crosses the right, we will stop, or it should be less, left should be less than right. Okay, so when then we will do the sum. If the sum is equals to target, then we will return true, or in the two sum question we have to return the left comma right in the form of array, which is this, left comma right. Okay, and if the sum is less than target, we will do the left plus plus, and if sum is greater than target, we will do right minus minus. Okay, so this was the two sum approach, which is only applicable for the sorted one. The array should be sorted to apply this two pointer approach. Otherwise, the optimal approach for this two sum is hashing approach, which we discussed.